Hello friends, this video on electricity part 13 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos till part 12 before going ahead with part 13. Here comes problem 3, which says two lamps, one rated 100 watts at 220 volts and the other 60 watts at 220 volts are connected in parallel to electric mains supply. Okay, so P1 for the first lamp, power is 100 watts. For the second lamp, power is 60 watts. The potential difference for the first one is 220 volts and the potential difference for the second one is also 220 volts. Now it says that they both are connected in parallel to electric mains supply. So what current is drawn from the line if the supply voltage is 220 volts? So let us see how much current will flow through this first bulb. So the current through this will be equal to P1 divided by V1. That's because we know that power is given as the product of potential difference and current. So this will be equal to 100 divided by 220 amperes. Similarly, current drawn by the second lamp will be equal to P2 by V2. That is equal to 60 divided by 220 amperes. Therefore, total current drawn by these two bulbs will be equal to I1 plus I2. So, total current drawn will be I1 plus I2, that is equal to 100 by 220 plus 60 by 220, that is equal to 160 by 220 amperes. This comes out to be 0.727 amperes. So this much amount of current will be drawn from the line. Let's look at the next problem. It says, which uses more energy, a 250 watt television set in 1 hour or a 120 watt toaster in 10 minutes? So let us try to calculate the energy for the first one. For the television set, power is given as 250 watts. And time is given as 1 hour. So 1 hour would mean 60 into 60 seconds. Now for the toaster, power is given as 1200 watts and time is given as 10 minutes. So 10 minutes would mean 10 into 60 seconds. Now we all know that power is nothing but work done per unit time. That means energy per unit time. Therefore, we can say that energy is equal to power into time taken. So, power is 250 into 60 into 60. So, this comes out to be 9 into 10 to the power 5 joules. Again, in this, energy will be equal to power into time taken. That is equal to 1200 into 10 into 60. So, this comes out to be 7.2 into 10 to the power 5 joules. So if you compare the value of E1 with E2, we see that E1 is greater than E2. That means the television set uses more energy than the toaster. Let us look at problem 5. It says an electric heater of resistance 8 ohms. So the resistance is given as 8 ohms, draws 15 amperes from the service mains in 2 hours. So the resistance of the heater is 8 ohms and the current it draws is 15 amperes in how much time? In 2 hours. So we have to calculate the rate at which the heat is developed in the heater. So in a way, we have to calculate the rate at which the energy is consumed by the heater. And what is rate at which energy is consumed? That is nothing but power. So that means we have to calculate power. Right? Now convert this time into seconds. It will be 2 into 60 into 60 seconds. Now how do we calculate power? We know that power is given by I square into R. So we really don't need this amount of time for which it takes this much of energy. So power is I square R. So I square is given as 15 square into R is 8 ohms. So this comes out to be 1800 joules per second. So this is the rate at which heat is developed in the heater. Two conducting wires of the same material and of equal lengths and equal diameters are first connected in series and then in parallel in a circuit across the same potential difference. The ratio of heat produced in series and parallel combinations would be which of these options? Now we know that heat produced is given by V square by R into T, because we know that heat, as per Joule's law of heating, heat produced is nothing but V into I into T. So applying Ohm's law, we can write it as V square by R into T. Now let us first look at the series combination. What would happen in series combination? Heat produced is denoted by Hs. This will become V square divided by Rs into T. What happens in parallel combination? In the parallel combination, Hp will be equal to V square divided by Rp into T. Now let us try to calculate the value of Rs, that is the equivalent resistance in series combination. This will be equal to R plus R, because resistance of both the wires will be same, because they are made up of same material, they have equal lengths and they have equal diameters, because resistance is given by rho L by A. So if they are made of same material, that means rho will be same. They are of equal lengths, so L will be same. They are of equal diameters, therefore area will also be the same. Therefore the resistance of both the wires will be same. So let us assume that the resistance of each wire is R. So equivalent resistance in series combination will be equal to 2R. Equivalent resistance in parallel combination will become 1 by R plus 1 by R. This implies Rp will become R by 2. Therefore, the ratio of the heat produced in series combination to the parallel combination will be equal to V square by Rs into T divided by V square by Rp into T. So this V square and T will get cancelled. So we get Rp divided by Rs. Now Rp is R by 2 divided by 2R. So R will get cancelled and we get 1 by 4. So Hs by Hp will be equal to 1:4. So if you look at it, option C would be the correct option. So with this we will conclude this lesson on electricity. So what all did we study in this lesson? We talked about what is electric current, what causes electric current to flow in a circuit, how do we draw circuit diagrams to represent electric circuits, what are resistors, how do we combine resistors in different types of combinations to get a desired value of resistance to complete a circuit. So these were some of the things which we discussed here, and we also talked about the heating effects of electric current. Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.